Alright, so Algebra Honors, we have Unit 6, Day 8 warm-up right now. So we've already done 3 of these problems, and I want you to try the back side of this page on your own first, and then check and see if you get the same answers here. So we did these 3 problems already, and now we're going to work on the problems that are on the flip side. So let's take a look. There, you can see it. Okay, so I have the square root of 3x squared y cubed all over 4 times the square root of 5xy cubed. I'm actually going to put that under the same radical just so I can see what I can simplify here. So I have one of these square roots of 3x squared y cubed. I have one of them, right? And then I have 4 of the guys over here. Oops, I wish I hadn't done that. Hold on one sec. Okay, sorry, I got a little excited with my fraction bar there. So I'm keeping my 1 and my 4. They're already outside of the radicals, right? So I'm going to keep them outside of the radicals. So I'm going to write the rest of my expression. Now I'm going to put it into one single radical. So I have 3x squared y cubed all over 5xy cubed. Okay, that's the quotient rule. So I had a radical divided by a radical, and I combined it under the same radical. Because now I can see I can do some simplifying. So I have 1/4 times the square root of 3/5. I can't really update. But x squared over x, that's just x, right? X to the 2 minus 1, so it's x to the 1. And then y to the third over y to the third, anything divided by itself is just 1, unless it's 0, and then we blow up the world. So, can you see that that's a radical? Sorry about that. Okay, so now I'm going to rewrite this as, I'm going to use the quotient rule and undo what I just did. So I have the square root of 3x in the numerator. It's 1 times the square root of 3x in the numerator, right? Over 4 times the square root of 5 in the denominator. Just using that quotient rule again. Okay, and I don't want to have a radical in my denominator, so I'm going to multiply the square root of 5 over square root of 5 here. Okay, I have square root of 3x, this is all under the radical, times the square root of 5, so that's the square root of 3 times 5 times x. So I'm going to say that's the square root of 15x, all under the radical. It's over 4 times the square root of 5 times the square root of 5. I apparently don't really want you to see my whole radical right now today. 4 times the square root of 5 times the square root of 5. Well, square root of 5 times square root of 5 is just 5, so this is going to be 4 times 5, and so my answer is square root of 15x, all under the radical, over 20. And I think to myself, well, 15 has factors. Is this all the way simplified? 15 has factors, but they're 1 times 15 or 3 times 5, so no perfect squares in there. So we're going to say that that is the final answer. Okay, here I think I will also put this all under the same radical. Of course, this is not the only way to do it, right? If you want to break up your whole numerator and your whole denominator and then simplify, you can do it that way also. I'm going to say this is 54x to the 5th y to the 3rd, all over 3x y to the 8th. So I'm going to simplify my radicand right now. Okay, so I know that 3 goes into 54. Right, 3 goes into 54, 1, 8, 18 times. Okay, so I took care of 54 and 3. X to the 5th over x is going to be x to the 5 minus 1, which is x to the 4th. And then I have y to the 3 over y to the 8. So one way you can simplify this is, what's the difference between those exponents? 8 minus 3 is 5. And then keep your answer, y to the 5th, wherever the larger exponent was. So I'm going to say that's y to the 5th. Okay, this is also y to the 3 over y to the 8, which is y to the 3 minus 8. Y to the 3 minus 8 would be y to the negative 5. And then you can put that back in your denominator to make it have a positive exponent. Okay, now I see that I can simplify this. It is the square root of, I'm going to say 9 times 2 times x to the 4th so that I can see perfect squares, right? And down here, that's the square root, I'm going to say, of y to the 4th times y, because I'm looking for perfect squares so that I can pull them out. So here, square root of 9 is 3. Square root of x to the 4th, I say 4 divided by 2, so it's going to be x squared. And I was not able to take the square root of 2 yet, so I still just write that as square root of 2. It's all over the square root of y to the 4th. I say y to the 4 divided by 2, so that's going to be y squared. And I was not able to take the square root of y, so I just still say square root of y. Oof, I'm almost done, except what do I have in my denominator? A radical. Okay, so I'm going to rewrite this just so I have more room over here. I'm not doing any actual math, just rewriting. Okay, I have square root of y in the denominator. I want to get rid of that, so I'm going to write square root of y over square root of y. And I have 3x squared times the square root of 2 times the square root of y. That's going to look like 3x squared times the square root of 2y when I use my product rule. All over y squared times the square root of y times the square root of y. You know that is y squared times y, which is going to be y to the 3rd. Okay, and do that out step by step if you need to, but I promise it's y to the 3rd. Okay. So square root of 16, x to the 5th, y to the 4th, all over 2xy. I'll go ahead and simplify inside first, although really you don't have to. Well, no, you know what? I'm going to do it the other way this time since I keep simplifying inside one radical. Watch this. I'm going to make this be the square root of 16x to the 4th times x to make that have a perfect square that I can see, times y to the 4th. This is all over square root of 2xy. If I simplify first, I get 4x squared y squared times the square root of x, right? Square root of 16 is 4. Square root of x to the 4th is x squared. Couldn't take the square root of x yet, but I have the square root of y to the 4th is y squared. Okay, this is all over the square root of 2xy. 2xy is all under the house. And so I'm going to... can I say square root of x divided by square root of x here? Sure. I'm getting rid of my x's, right? Because that's square root of x times square root of x. So that just leaves me with square root of 2y down here. You okay with that? Think about that if you're not okay with that. I multiplied, or I had the square root of x in the numerator. I had square root of 2 times square root of x times square root of y in the denominator. That's why I could do that. Okay, so now I'm going to multiply by the square root of 2y over the square root of 2y. And I have 4x squared y squared times the square root of 2y. All over square root of 2y times square root of 2y is just 2y. I'm not done. Oh, I thought I was going to be done, but no. Look, I have 4 over 2. That can be simplified. And I have y squared over y. That can be simplified. So I'm going to say 4 divided by 2 is 2. 2 divided by 2 is 1. I'm going to say y squared divided by y is just going to be y to the 1. Okay, 2x squared y times the square root of 2y all over 1. And I don't even need all over 1, do I? Because that's just a little extra writing that we don't even need to have. Come on, little white tape. Okay. Poof. Go away. Okay, I also could have done this by saying square root of 16x to the 5th, y to the 4th, all over 2xy. And here I would get square root of 8. X to the 5 over x is x to the 4. Y to the 4 over y is y cubed. And so if I rewrite that to have perfect squares, I would have square root of 4 times 2 times x to the 4th times y squared times y. So I have perfect squares to take out, and then I have 2 and y to leave in. And that's going to give me that exact same answer over here. All right, a challenge. So our challenge has cube root instead of square root. So I know that this is the same thing as saying the cube root of 3 over the cube root of 4y squared. I just use that quotient rule. And I don't want to have a radical in my denominator, so I'm going to multiply by that whole giant, enormous, messy radical. Cube root of 4y squared over cube root of 4y squared. Try this yourself. Okay, and so I know in the denominator, well, I suppose I'll do the numerator first since that's what I did everywhere else. Cube root of 3 times cube root of all of that. I'm going to combine it under the same house. So cube root of 3 times 4 is 12 there, y squared. My denominator, the cube root of 4y squared times the cube root of 4y squared is the cube root of 4 times 4 is 16. Y squared times y squared is y to the 4th. So, that time when I multiplied by cube root of 4y squared, when I multiplied by the denominator over the denominator to try to get rid of it, it didn't work, did it? Because these are not all perfect cubes. So I'm going to have to kind of change my approach, I think. So maybe I'll simplify this and see what I end up with. I end up with, let's see, that's going to be the cube root of 12 over 16. I'm going to divide everything by 4. Oh no, if I divide everything by 4, I'm just undoing everything I did. Okay, so what am I going to do? Well, I think that since it's cube root, I need it to multiply 3 times instead of just 2 times, right? So let's try again. I have the cube root of 3 over the cube root of 4y squared. So what if I multiplied by, because I want to get rid of this cube, so what if I multiply by the cube root of 4y squared times the cube root of 4y squared? So stay with me. Let's see if we can make this work, okay? All over the cube root of 4y squared times the cube root of 4y squared. Okay, see why I'm actually now having 1, 2, 3. So I'm going to rewrite this so you can see what crazy talk I'm doing here. Okay, I have the cube root of 3. I am going to multiply all this stuff. 4 times 4 is 16. Y squared times y squared is y to the 4th. Because I'm going to assume what I'm doing is going to work. Okay, so I've done part of my multiplying up here. This is all over. Watch this. This is actually 4y squared under the radical, right? But I have how many of them? 1 times 1 times 1. I have 3 of them total. So the cube root undoes the cube. See what I did? Before I had the square root undoes the square. This time I'm doing the cube root undoes the cube. So now if I keep doing my work up here, I have the cube root of 48y to the 4th. And it's all over. I undid that cube root, so it's just 4y squared here. Yeah? Okay, so 48, I'm looking for cube roots. So I'm going to actually rewrite this as the cube root of 8 times 6 times y to the 3rd times y. Now I have some perfect cubes. It's all over 4y squared. Yeah? Okay. So when I take those cube roots out, I'm just going to do it right here and hope that I'm going to have enough room. Cube root of 8 is 2. That's done. Cube root of y to the 3rd is just y. Poof, that's done. So I still have the cube root of 6y because I wasn't able to take the cube root of 6 or the cube root of y. This is all over 4y squared. I am nearly done. 2 goes into 2 one time. 2 goes into 4 2 times. And I have y to the 1 over y squared, which I'm going to say leaves me with a single y in the denominator, right? So y to the 1 over y squared is going to leave me with just y in the denominator. But I also have 2 in the denominator, 2y. And then up top, all I've still got is cube root of 6y. So woof, that was a lot. So the lesson that we have learned is when we're rationalizing the denominator of a square root, we're going to multiply just by the denominator, right? If I'm rationalizing the denominator of a cube root, I need to multiply by whatever my denominator is twice in order to get rid of that cubed situation. I'm thanking you for watching. All right, have a great day.